Pretty good at making roads inside of volcanoes. CCC finished it up. Yeah, CCC. The CCC is the Civilian Conservation Corps. That got later rotated into AmeriCorps. Yeah. Yep. It was a New Deal program from FDR to get people back to work. Yeah.
What's causing the mud pots to move around?
That is a very good question. What makes mud pots move? So there's a number of different ways that they move around. They're acidic, so they can eat away at one area and then exploit that new weakness, like move to it. Also, with the steam coming up, there's sulfur that's being deposited with that steam. So as crystals grow inside of the vents, they can plug it up and then force the steam out in the new area. Or when earthquakes happen, an earthquake will happen, close up one vent and open up another. So there's a variety of different mechanisms that they can move around. And not only do they move from place to place, they also change from one feature to the other depending on how much water is in. So in the springtime when there's lots of water, there's lots of boiling springs. And then as the summer goes on and things dry out, they turn into boiling mud pots, and then the mud pots will turn into steam pits. And then in the wintertime when the water comes back, that all gets reversed. So they move around from place to place, they change from one feature to the other. You guys come back in a couple months, this place is gonna look different. It's pretty amazing. There's not too many places where you can see geology happening. And last one. You know, I've never. This one will move back into the hill, but it won't move up the hill. Yeah. Part of it. Yeah. Part of it. Because you can see where they were up there. That orange stuff up on the hill over that way. That used to be hydrothermal areas up there. Oh, absolutely. This place is good. The question was if there's seismic activity. This place is almost constantly shaking. We just can't feel it. Our seismographs are sensitive enough, though. Or seismometers are sensitive enough to feel it. There's like 3 or 4 magnitude 1 earthquakes every day. There might be one going on right now. Almost constantly shaking. Cool. So, not only is this place dynamic on these little human timescales that we can observe over the course of like decades, this place is also very dynamic on these really big geologic timescales over millions of years. So, this broke-off volcano that we're inside of right now is not the first volcano to suffer its fate to get built up like that and then eroded away again. That's happened at least 5 times in this immediate area over the last 3 million years. If we were here 3 million years ago, we'd see a giant mountain to the south of us. It was called the Maidu, and it's probably about the size of Shasta. That got built up and eroded away. Now it's left with a little mountain called Butt Mountain, which is kind of a funny name. If we were here a million years ago, we'd see twin volcanoes to the south of us. One over the town of Mineral, the other over the Warner Valley in the south central part of the park. Both of those got built up and then eroded away again. And then on this exact spot before Brokaw was here, there was another volcano called the Brockman. Now it was built up and then knocked back down. So this place is kind of like whack-a-mole. You guys ever played arcade game whack-a-mole? You know, ball sticks head up and pop over the head of the mouth. Yeah, so that's kind of like what's happening. That mole pushed up, making a volcano that's like the mole sticking its head up. And erosion's like the mallet, and it knocks it back down again. This process has been going on for about 3 million years in this immediate area, and there's no sense to stop it soon. The Montefuca plate, which is the oceanic plate up the coast here, that's the one sitting up beneath the continent that's melting. And that magma's going to come up to the surface. When or where it's going to come up, but it's very, 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 very common. Yeah, it's a story. Bumpus Hill is closed on account of snow. They opened it for like 36 hours a couple weeks ago and had to do like the helicopter rides out there. So they decided it's probably not a good idea to have it open. And they'll open it back up once the snow melts out more and people don't break ankles. Okay, so eruption warnings. This area is monitored by the United States Geological Survey, the California Volcano Observatory, and Menlo's Park watches it. So all of the seismometers and GPSs around here, all that data is live streamed down to Menlo's Park there. And they get about 2 weeks to a month's warning before eruptions happen. They look for shallow earthquakes that get shallower, ground movement, and increases in gases in the hydrothermal areas lets us know that the magma is close. that is actually a really good point. So we live. Let me back up for a second. So if we look at places like sulfur, it gives us insight into all sorts of things, right? We can like use it as insights into how hydrothermal systems work. We can use it as a window into plate tectonics and to see how the Earth functions. We can even use it as an analogous for life on other planets. But if you're not a volcanologist, if you're not a geologist, if you're not an astrobiologist, like who cares? You know, like volcanoes blow up and that's cool and everything, but like why should we continue to study and care about volcanoes? Mount St. Helens, right? We live in, on, and around volcanoes. It's kind of handy to know when one's going to go off, right? So I said earlier that we have like 2 weeks to a month's warning before eruptions happen, but that's no guarantee or let me start over. We have 2 weeks to a month's warning before eruptions happen, but there's still a lot of work to do with our prediction techniques. So we could have all the signs and symptoms of an eruption, but that's no guarantee that an eruption is going to happen. We also don't know what type of an eruption it's going to be. It could be a little trickle of lava down the side, or a big explosive thing like St. Helens, and we have no idea. So that's why it's so important to keep studying this place and keep preserving it, so that we have a baseline here of a volcano that's unaffected by humans, so that we know how to monitor these things in the future. A lady named Nancy Newhall said it really well. She says that the wilderness holds the answers to the questions we yet know to ask. So 100 years ago, when this place was created as a national park, we had no idea that NASA would be here trying to use this place as an analogous to look for life on other planets, right? We didn't know how to ask those questions. NASA didn't even exist back then. So that's why it's so important to keep preserving this place. And as you go throughout the park today, I really encourage you to slow down and get out of your cars. Go for hikes, pick up cool rocks, and look at them, because there's so much we don't know. Definitely put the rocks back when you dump them, please. But definitely pick them up and look at them. So thanks for coming out with me today, and I hope you all have a blast in the park.